What we're going to look at now is quadratic functions that are in standard form. We're going to be finding the vertex. Remember that standard form is y equals ax squared plus bx plus c equals 0. That is standard form. What we're used to working with for graphing is vertex form. So this is going to be a little bit different. One way we've found to find the vertex when it's in standard form is to complete the square. But there's actually another method for finding the vertex in standard form. What we're going to do is use the formula for the x-coordinate. So the vertex will be at, there's going to be a formula for the x-coordinate. So the x-coordinate will be x equals opposite b divided by 2a. And we're also going to use that for another feature of these parabolas here in a second. So the x-coordinate will be opposite b over 2a. Now remember when we were plotting these y equals ax squared plus bx plus c using the xy chart, and if we had an x value, how would we find the y value? Remember that we would use that xy chart. So basically, once we know an x coordinate from opposite b over 2a, to get the y coordinate, we're just going to plug that in. So we're going to plug that in for x to get y. So the x coordinate, x equals opposite b over 2a. The y coordinate, we're going to substitute the x value into the equation. Now let's think for a second about what these parabolas look like. Parabolas are that U shape, so our quadratic functions are U-shaped. They could open up or they could open down. And they have a vertex that goes through either this point here or this point here. Now if we drew like a vertical line through that vertex, that vertical line would cut the parabola exactly in half. And that vertical line is actually called the line of symmetry. We have a line of symmetry here, and we have a line of symmetry, I'll abbreviate it LOS, line of symmetry for that other parabola. Since that line of symmetry goes right through the vertex and it is a vertical line, the line of symmetry has an equation, x equals some number. Well, the number that it equals is the x-coordinate of the vertex. So let's go ahead and add the line of symmetry into our notes. The line of symmetry is a vertical line through the vertex. And it has the equation x equals opposite b over 2a. Now let's compare our standard form and vertex form for finding the vertex. So this is kind of going to be a little bit of examples for finding the vertex. So let's say we have a vertex form and standard form. So our vertex form will have y equals x plus 2 squared minus 5. And standard form, let's have y equals x squared plus 4x minus 1. So let's find the vertex in our vertex form. Remember we're going to use transformations to do that. So this is a shift left 2, and this is a shift down 5. So if we shift the vertex left 2 and down 5, we will have a vertex at -2, -5. Now, since we just talked about line of symmetry, we know that this parabola is going to have a line of symmetry that goes through the x-coordinate. So we can write the equation for the line of symmetry. That will be x equals -2. Now let's talk about the stretches or reflections that this parabola has. Remember that stretches or compressions and reflections would be the coefficient right here. Since this doesn't have any value besides 1 right there, there are no stretches or compressions, so we will build the parabola by that pattern. No stretches or compressions, so we will go over 1, up 1, over 2, up 4, over 3, up 9 from our vertex at -2, -5. Let's look at our standard form. In standard form, we're going to find the vertex by doing x equals the opposite of b over 2a. So x equals the opposite of b, so opposite of 4, over 2 times a is 1, 2 times 1. So x equals -4 over 2, or x equals -2. Now that's just the x part of my vertex. So the vertex will be at -2 comma something. And we get the y-coordinate by subbing -2 in for x in that equation. So the y-coordinate, y will equal -2 squared plus 4 times -2 minus 1. So we get -2 squared is 4, plus 4 times -2, which is -8, minus 1. So 4 and -8 is -4, minus 1 is -5. So y is -5, and that's where the vertex is. The line of symmetry for this graph goes right through that x-coordinate of the vertex, so it will be x equals -2 as well. Now you're going to notice that I have the same vertex for these two parabolas. Well, that's because they are the same parabola. So let's look at, in the next section we're going to be looking at what part of this equation would tell us if we have any stretches or compressions. And the place that we look for that is in the same place that we had A for our vertex form. Remember, in vertex form, A was the coefficient out in front. Well, in standard form, A is the coefficient in front of the x squared. So we might want to make a note of that. In vertex form, we have y equals ax squared plus bx plus c. That A value tells you if there is a stretch or compression, and it also tells you if it's negative, there will be a reflection. So that's where we can find that A value, what we can use that A value for. In the next section, we'll be looking more at standard form and how we can graph using it.